Very good afternoon to all my beloved students. Today I have to discuss the topics of linked list. Now, before starting this part, at first I have to just discuss about the list versus array. Okay, that is here some plus and minuses are there related with this array part. That is the positive part is that is plus part, this first element accesses, and the negative part is impossible to resize. That is when the array size is fixed, then we cannot change its size. And many applications basically require the resizing, and this request size not always immediately available. Now, basically, when we compare the linked list versus array, both arrays and linked lists can be used to store linear data of similar types, but they both have some advantages and disadvantages over each other. Now, at first, we have to discuss the key differences between array and linked list. Now, an array is the data structure contains a collection of similar type of data elements, whereas the linked list is considered as non-primitive data structure contains a collection of unordered link elements, which is known as nodes. Next point. In the array, the elements belong to indexes. That is, if we want to get into the fourth element, if we have to write the variable name with its index or location within the square bracket. Now, next point, in the linked list though, we have to start from the head and work our way through until we get to the fourth element. Now, accessing an element in an array is fast, as I told, while linked list takes linear time, so it is quite a bit slower. Operations like insertion and deletion in arrays consume a lot of time. On the other hand, the performance of these operations in linked list is fast. Next point, arrays are of fixed size. In contrast, linked lists are dynamic and flexible and can expand and contract its size. In an array, memory is assigned during compile time, while in a linked list, it is allocated during execution or runtime. Next point, elements are stored consecutively in arrays, whereas it is stored randomly in linked list, which I describe later. Now, next point, the requirement of memory is less due to actual data being stored within the index in the array. As against, there is a need for more memory in linked list due to storage of additional next and previous referencing elements. And the last point, that in addition, memory utilization is inefficient in the array. Conversely, memory utilization is efficient in the linked list. So in the next slide, I have to describe the singly linked list at first. Now, basically, an array is a static data structure. That is, the total number of spaces to keep data elements in an array whenever defined in a source program remains constant during execution time of the program. So during execution time, we cannot change the size of an array, as I already told. Hence, the spaces defined for an array may be wasted during runtime, or more spaces may be required in execution time. Now, if we allocate memory spaces during execution time, depending upon the need of user, then it will be more flexible. From this aspect, the concept of linked list is derived, and linked list is dynamic data structure. So a singly linked list is a concrete data structure consisting of sequence of nodes, and these are the nodes. Look, these are the nodes, and here in this example, 4 nodes we have to consider. Now, then the definition of linked list we can derive as that a linked list is a dynamic linear data structure which contains a collection of data elements. For example, in this slide, the data elements are A, B, C, and D, right? And these are called nodes, where the linearity is maintained by means of pointer, and these are the pointer. That is, it points to the next node in this way. Okay, and as this is the last node, So here null pointer here we assign, that is 5 means null pointer. Now so each node stores two parts. One is for element, that is in this example A part, for example the first node, and next one is linked to the next node. So in this way the first node points to the next node, and next node the data element here is B, and it will point to the next node. So here in this case the data element contents is C, and this node points to the next node. Here the data elements contents is D, and as this is the last node, so this node next pointer part is null or 5, as I described in the general pattern of singly linked list node, right? Now next part we have to consider what are the advantages. That is why we use the singly linked list. Now the number of nodes in a linked list can be increased or decreased during runtime of a program. That is, linked list is dynamic in nature. So in this technique, memory can be allocated or deallocated whenever required. That is, memory can be utilized efficiently, right? Next point, insertion and deletion operations are easier and efficient. And lastly, many complex applications like polynomial addition or multiplication can be done more efficiently in singly linked list. And some disadvantages are there. That is, what are the disadvantages? Here, random access is not possible. And next one is that in each node, extra memory spaces are needed to store the address of the other node. That is this part. So each node contains two parts. First one is the data element part, and next one is the next node pointer part. So this extra basically memory space here needed, right? So this is also a disadvantage. Now next part is what are the operations can be performed on linked list. Now there are several types of operations associated with a list of data structure. That is in this case linked list. That is number one, counting total number of nodes. Next one is insertion of a new node in the list. Next one, deletion of an existing node from the list. Next one, searching a specified node in the list. And lastly, display all nodes of the list. Okay, so these are the operations we can perform here, right? So this is the basic summary portion of the singly linked list, right? And here in node class must store the data and the reference to the next node, and this part is also treated as a pointer part. And all of you know that pointer is the variable which contains the address of another variable, right? Now before describing the structure definition for each node part, at first I have to discuss the types of linked list. Now there are two types of linked list depending on the number of links. First one is singly linked list. As I already told in the previous slide, that is in this list each node has only one address field to contain the address of the next node in the list. Okay, and here, so that's why each node has two fields. First one is data field to store the information, and the second field is link field which contains the address of the next node in the list. So from the concept of self-referential structure, the structure definition for each node in singly linked list is defined in this way. That is, here struct node, at first struct means basically structure part, and here each part contains the two part. That is, first one is the data value part, and second one is the pointer to the next node, right? And here in this case, here I consider the data element type is integer. Okay, and when it points to the next node, that's why here we write down struct node star ptr next, as it is a pointer. So after that we rename the data type of each node as a SLL node. So that's why here we have to define type def, that is type definition, and this node is now treated as SLL, right? So here each node has two fields, and first one is the data field to store the information, and the second field is link field which contains the address of the next node in the list. So from the concept of self-referential structure, the structure definition for each node is treated in this way, right? And second one is the doubly linked. Here, each node contains two pointer fields. One contains the address of the next node and the other link keeps the track of the previous node in the list, right? So now, laterly, we have to, when discuss about the doubly linked list, then we have to elaborately discuss this thing, right? Now, this is the memory layout of the singly linked list compared with an array, right? Now, here in this case, we have to consider 5 elements, that is A, B, C, D, E. So, when we discuss about the array representation for storing these 5 elements, the part is shown in this way, that is this part, right? So, here we look one by one contiguously, these elements are stored in an array, right? But when this element we have to store in using linked list, the stored pattern is this one. That is, this is the arbitrary layout, right? So here, this first element of A is stored in this cell. The second element of B stored here. Now there is the next pointer part, and with the help of this next pointer, that is the part of A is linked with B. Then with the using of next pointer, part of B is linked with then next element, which is C. Then with the using of next pointer, this element of C part is linked with then D, and finally this D part linked with E. So in this way, we have to access the elements in singly linked list, right? So that's why, in other words, we have to say that when we consider the linked representation, here we are using the arbitrary layout, right? Now in the next slide, we have to consider the counting the total number of nodes using a linked list, right? In this example, here we have to consider 3 nodes, right? Now before discussing this part, at first I have to write down the algorithm part of the counting of the total number of nodes in a linked list. So I have to write down the algorithm part at first, that is counting the total number of nodes. Okay, so here in this case, at first the algorithm name I have to consider that FNN SLL this. Okay, so this is the first line, so I have to line 1. Okay, now here in this case only one argument we have to use, that is ptr start, right? And the purpose of this algorithm is to count the total number of nodes in a singly linked list. If we omit the line number, then we have to omit it, no problem. Okay, now here basically ptr start is the address part of the first node. Okay, so this part is the address part of the first node in the list. Okay, now here the output of this algorithm returns the total number of nodes, and here this part will be counted as I count, right, which is used in the list. Okay, so at first we have to define, that is new pointer ptr temp of SLL node, right? So we have to write down this thing, that is here, this. Okay, so it basically create a new pointer ptr temp of SLL node type, right? Now after that we have to initialize the ptr temp. Now the initialization part is ptr start, as it used in the argument portion of this function. So in the next line we have to write down this. Okay, now after that we have to initialize the count, and that counterpart as I used is I count. So I have to write down I count is equal to 0, right? So I have to copy it, I count is equal to 0, that is initialize the counterpart. Okay, now repeat the steps inside the while loops until ptr temp reaches null. So here using the while loop, I have to write down the code, that is while this. Okay, and inside it, that is until the ptr temp reaches null, at one by one I have to increase the counter value at first, that is I count is increased by 1 unit every time. Okay, and after that the increment part of the I count, then advance the ptr temp to the next node by using this code, that is this. So this. Okay, so this part continues until and unless this ptr temp reaches null, and finally return the total number of nodes by return of I count. Okay, so I have to write down this return of I count. Okay, and after that we have to close our function part or algorithm. So end of the algorithm, right? So this is the algorithm part for counting the total number of nodes in the linked list. Okay, now go to this slide part. Okay, that is when I reaches the slide section, that is this part, counting the total number of nodes. So according to this algorithm, here in step 1, ptr temp equal to ptr start, right? So that is this part. So ptr start point to this, so ptr temp right now point to this node, right? Now in the next step, here we go for the while loop. Now ptr temp is not equal to null, this part is true, so I count equal to 1, and ptr temp is advanced by 1 node, right? Now in the next step, again it will check ptr temp is not equal to null, it is true, so I count equal to 2, and ptr temp is advanced by 1 node, right? So ptr temp right now points to this. So in the again ptr temp is not equal to null, that is previously ptr temp points to this. Now again when ptr temp is not equal to null, this is true, so I count equal to 3, right? And ptr temp is advanced by 1 node, right? Now here after I count is 3, ptr temp is advanced by 1 node. Okay, now in the last node, that is the node which contains the data elements 40. Okay, here ptr temp is null, right? So the while loop not executed, that is here as ptr temp equal to null, so while loop not executed, so control goes to the outside of the while loop, right? So which returns the value of I count, here is 3. That is in this case the total number of nodes here will be 3. Okay, so in this way we have to count the total number of nodes in a singly linked list, right? Now the next part, that is in the next slide, we have to discuss the find the address of the nodes at the specific position in singly linked list. Before I discuss it, at first I have to discuss about the algorithm portion of this section, right? So I have to go to the again notepad, and here this previous part I have to omit it, okay, which is the algorithm for counting the total number of nodes part. So here in this case, for finding the address of the nodes at the specific position, so here again I have to consider the algorithm name is FNN-SLL find underscore position. Okay, so this part I have to write down one by one. So this way we have to write down, that is here I have to write down this thing, that is this. So this part. Okay, now here I have to use the 2 arguments, that is one is for ptr start and another one is for I position, right? And this algorithm finds the address of a specific node. Okay, and here the ptr start is address of the first node and address of the node at I position in the list is required, right? And this algorithm returns the address of the node, and for non-existence position it will return 0, right? Now when this algorithm start, at first we have to create a new pointer, that is ptrtemp of SLL node type, right? So I have to write down this thing here. Okay, now in the next line, here we have to initialize the ptrtemp. So ptrtemp equal to ptr_start. We have to write down, because ptr_start points to the first one. Okay, so we have to write down this. Okay, now in the next part, here we have to consider this function, that is here, as I told you, that if position is negative or greater than total nodes, then it will return 0 value. Okay, right? So for checking this condition, I have to use the condition inside the if condition, and already this function or this algorithm part already covered, that is fn SLL ptr_start in the earlier section. Okay, now if this condition is satisfied, right, then it will return the 0 part, that is it will return 0 value. Okay, so it will return 0 value. Okay, otherwise, that is in the else block, here I am not write down in the else explicitly, so we go to the particular node using one for loop. So here I counter starts from 1, that is the first node. Okay, so in the for loop we have to write down this thing. Okay, now one by one we have to assign to the next node by ptrtemp equal to ptrtemp arrow ptr next. So one by one we go to the next node in this way, and finally when we return the address, we have to write down return of ptrtemp. Okay, so we have to write down return ptrtemp, then we have to close our algorithm. So in this way we have to find the address of a node at specific position of singly linked list. Okay, now we have to go to the PPT portion and show how this algorithm basically works. Okay, so here in this example, here we have to consider the 3 nodes, right? And the ptr_start points to the first node, where the first node contains the data element value is 10. Now suppose we want to find the address of the third node in this linked list. So I position equal to 3, right? Now at first the step 1, it says that ptrtemp equal to ptr_start, right? So ptrtemp is right point to this one, because as ptr_start points to this node. Okay, now in the next step, here value of I position is not negative or not greater than the total nodes. So we have to go to the next step, right? And that is the for loop. Okay, and this for loop executes 2 times, that is 1 to 2, and accordingly ptrtemp is advanced by 2 nodes in this part, and finally ptrtemp is pointing to the third node in the list. So return of ptrtemp here basically points to this node, that is third node, right? Okay, so in this way we have to find the address of a node at the specific position. Okay, now in the next slide we have to discuss the another operation of linked list, that is called inserting a node in a singly linked list. Okay, now for the insertion of a node in a singly linked list, we will use a pointer variable ptr_start to keep the track of the first node in the list. Initially ptr_start is set to null to indicate that the list is empty. Now consider the singly linked list here, that is this part. Now consider this part. Okay, now here a new node, that is PTR new node, is to be inserted after the node PTR temp1. That is after the node of PTR temp1, a new node, that is PTR new node, is to be inserted. Okay. Now the data value of the new node, suppose, is 30. Okay. Now here, this is the part for creating the new node. Okay, using the malloc function. So this node is created using this malloc function, right? Now, before describing this operation, at first we have to discuss the insertion algorithm of a new node in a list. So again, we have to go to the notepad portion where we have to write down the insertion algorithm part. Okay, so I have to omit it. Now here in the insertion portion, okay, so here suppose the algorithm name is FNN-SLL underscore insert, and here we have to consider the two arguments, that is one is for PTR temp1 and another one is for data part, right? Now here I have to write down this algorithm part, and this algorithm inserts a new node in a singly linked list after a given node. So I have to write down this algorithm here. Okay. Now here the new node with data value, that is data, is to be inserted after node PTR temp1. Okay. Now we have to create a new pointer for the new node. So I have to declare this thing, that is this part. Okay. Now after that we have to create the new node, as I already shown in the slide section, that is creating a new node using malloc function. So we have to create the new node using malloc function. Now after that, set the data value into the new node. Okay, so we have to set the data value in the new node by using this code. Okay, now after that, the new node now points to the next node of the given node. So how this is possible? By simply write down this code, that is this part. Okay, now after that, the given node points to the new node. So how can we assign that given node now points to the new node? By simply write down this code, that is this part. Okay, now after that we have to close our algorithm section, that is we have to write down the close brace. Okay, so here we have to write down the close brace part. Okay, so in this way we have to insert a new node in a singly linked list. Okay, now we have to go to the slide section, and here we have to discuss that how this operation is possible. Okay, that is this part. Now look here, in this case, that is when I go to the next slide, that is here, this linked list contains total 3 nodes. Now the new node is created, PTR new node, in the previous slide with the help of this malloc function. Okay, now PTR new node equal to SLL node star malloc size of SLL node, and this part is used for creation of the new node, namely PTR new node. Now we have to assign the element value 30 to the PTR new node, right? So here we have to assign it the 30 part. Okay, now after that, after assigning the data value of 30 to the PTR new node informative part, then we have to write down the step 3, that is PTR new node arrow PTR next equal to PTR temp1 arrow PTR next. Okay, so in this case this link will be created. That is, you see this link, that is this part is created. Okay, and so in this case, this ptr new node link field right now points to this node where the data item is 40 with the help of this syntax, right? Now after that, that is when we assign that ptr temp1 arrow ptr next equal to ptr new node, then this ptr new node is pointed by this second node, which is ptr temp1 link field. So ptr temp1 link field right now points this part. Okay, so in other words, we can say that this ptr new node next pointer points to this node, whereas the second node, which contains the data item of 20, and that node is ptr temp1, this link part points to ptr new node. Okay, then in this context, we have to say that this ptr new node is properly inserted in between ptr temp1 and the last node, which is 40, right? So in other words, we have to say that we have to insert a new node whose data item is 30 is properly inserted in between the two nodes, namely ptr temp1 and the last node in this diagram where the data item value is 40. Okay, so in this way we have to properly insert a node in a singly linked list. Okay, so here in the next case we have to go to the notepad portion where we have to discuss the next algorithm part. Okay, and here at first we have to erase this thing. Now here the algorithm is to insert at the beginning part. Okay, now in the next slide we have to discuss it elaborately. So insert at the beginning, here the algorithm contains here also the two arguments, right? That is, one is for ptr start and another one is for data. Okay, and here the name here at first I have to write down that this is the insert at beginning portion. So insert at beginning, so I have to write down this insert at beginning. So here we have to use the two arguments. Okay, now the purpose of this algorithm is to insert a new node at the beginning of the list. Okay, and this ptr start is the address of the first node and data is the data value of the new node, right? And this algorithm returns the address of the first node. Now address of the first node is ptr start, right? Okay, now after that we have to at first declare the ptr new node by sll node start ptr new node. So we have to write down this thing here. Okay, now here we have to at first create the new node by using the malloc function. So we have to write down this code is ptr new node equal to sll node star malloc size of sll node. Okay, now after that we have to copy the data value into new node, right? So we have to write down this thing. So this copy data value part. Okay, then after that new node now points to the currently first node by using this syntax. That is, write down this. Okay, there. Now we have to set new node as the first node in the linked list. So we have to assign it this, that is ptr start equal to ptr new node, right? and after that we have to return the updated address of the first node. Okay, so that's why we have to write down return of ptr start, that is this. Okay, and we have to close our algorithm. So in this way we have to insert the node at the beginning portion of the linked list. Okay, and in the next video lecture we have to show it elaborately, and then we have to consider another operation, that is insert at the last of the list, and more and more. Okay, so today I have to close our this part of this algorithm section. I have to close it, that is the last part is insert at the beginning portion of the singly linked list, that is insert a particular node at the beginning portion of the singly linked list. So I have to close my today's topic of singly linked list.